We want to use fundamental identities to write the first expression in terms of the second for any acute angle theta. So we start off with cotangent theta, and we want to represent this in terms of sine theta. So we're going to start off with cotangent theta, we know is cosine over sine. And sine squared plus cosine squared is equal to 1, which means cosine squared is 1 minus sine squared. So cosine will just be the square root of 1 minus sine squared. The direction said we need acute angle theta. Okay, so typically you would have plus or minus, but because we're looking at acute angle theta, that means theta has to be between 0 and pi over 2. So it's in the first quadrant. We know cosine is positive in the first quadrant, so we're going to leave it as the positive square root of that. So we're going to replace it here. And that is our answer. Next example, we want tangent theta in terms of cosine theta. So this is going to be similar. We know that tangent theta is sine over cosine. And sine squared plus cosine squared is 1. That makes sine equal to the square root of 1 minus cosine squared. And because we're looking at an acute angle theta, that means theta is in the first quadrant between 0 and pi over 2, and sine is positive in that quadrant. So we're just going to leave it alone, and we have the square root of 1 minus cosine squared over cosine is my final answer. Next, we want to write secant theta in terms of sine theta. So for this one, secant theta is 1 over cosine. And cosine, from the previous examples, we said a cosine was the square root of 1 minus sine squared. And again, for all of these questions, we're going to let theta be between 0 and pi over 2. Okay, we want to represent cosecant theta in terms of cosine theta. Cosecant theta is 1 over sine theta. And sine theta, we said, is the square root of 1 minus cosine squared. And this is for theta in the first quadrant. Now we want to represent sine theta in terms of secant theta. So sine theta, we can write it as tangent theta over secant theta, right? Because that's equal to sine theta over cosine theta, and then 1 over cosine theta. So the cosine thetas are going to cancel, and you get sine theta. So that's why sine theta is equal to tangent theta over secant theta. Okay. So secant theta is good. Now we want to change tangent theta. Well, we know that 1 plus tangent squared is secant squared. So tangent will be the square root of 1 minus secant squared. And we're going to be looking in the first quadrant again, because we want an acute angle. So we're going to replace tangent theta with the square root of 1 minus secant squared theta over secant theta. And that's what sine is equal to. Last example, I want to represent cosine theta in terms of cotangent theta. Cosine theta is cotangent theta over cosecant theta. And that's because cotangent theta is cosine over sine. Cosecant is 1 over sine. Sines are going to cancel, and you're just left with cosine theta. Okay, so I'm going to use next the identity 1 plus cotangent squared is equal to cosecant squared. So then cosecant will just be the square root of 1 plus cotangent squared theta. And here we're going to let theta be between 0 to pi over 2. Okay, so we're going to have cotangent on the top and then the square root of 1 plus cotangent squared on the bottom. And that's all going to equal cosine theta, where theta is between 0 and pi over 2.